Hi, in this last video on NMR, I'm going to go through 3 different NMR spectrums and show you how I solve these questions that will be very common on a quiz or a test dealing with NMR. So in general, you'll be given the spectrum and you'll be given the number of atoms in it. So in this case, we got C3H8. But I don't know what the structure of this is. Right? There's a lot of different ways a C3H8 could be structured. So first thing I always like to do is I calculate the degrees of unsaturation. This will tell me if I have any double bonds or rings. So the equation for it is it's 2 times the number of carbons plus 2 plus the number of nitrogens minus the number of halogens minus the number of hydrogens, all over 2. So in this case, it's going to be 2 times 3 plus 2 minus 8 over 2. And this is, 0 over 2, so 0. So I have only single bonds here. There are 2 signals. So that's what I note next. So 2 signals. We have a triplet here, and this looks to be a multiplet. So triplet and multiplet. A common triplet that you'll see is if you have a carbon with hydrogens on it, and it's a terminal group, so it's like a methyl group, and next to it is a carbon that has 2 hydrogens. So I'm thinking we might have something like, we could have a structure like this, where I'll draw in the hydrogens in a different color. These 2 would be the same signal because of symmetry. Right? I could just put symmetry right down the middle there. Okay. So the splitting on these would be a triplet, right? It would be 1 plus the 2 green hydrogens to give you a triplet. Then the signal here would be a multiplet because it would be 1 plus 3 plus 3 to give 7. So this corresponds to what we have. So it looks like the answer for this first one is propane. Right? A good strategy is write down a structure you think it might be and then check it based on the spectrum. If it doesn't match up, then make changes and try again. Right? NMR spectrums, especially once you get to complicated ones, is a lot of trial and error. So give it your best shot, see what structures in your compound work with the NMR, and if there's some that don't, then try to fix that and keep going until you're able to get it. It's not something that often one try gets it done. So don't get discouraged if it takes you 2 or 3 or 4 tries of drawing out a structure till you can get the correct compound. Example number 2, C4H10O. Immediately I note 2 signals. Right, this guy down here is not a signal, that's the standard TMS. So I have 2 signals. This one looks to be a triplet, and this one looks to be a quadruplet. So triplet and quadruplet. When I do the degrees of unsaturation now, it's going to be 4 times 2 plus 2 minus 10 over 2, and that's going to give me 10 minus 10 over 2, which is 0. So again, no double bonds, no rings. All right, so a quartet and a triplet, no double bonds, no rings. Now there's 4 carbons, but only 2 signals, so there has to be symmetry. Second thing, we have an oxygen, but it's not a carbonyl because we have no double bonds, and it's not an alcohol because we have no OH signal. And I know the OH signal doesn't always appear, but because we only have 2 signals and we need symmetry, there's no way we can get symmetry with the carbons if we have an OH group. So I'm thinking ether here. We probably have an ether. So oxygen, and since there's 2 signals and 4 carbons, 2 carbons on each side, that would be my first guess, because now we have the symmetry. So let's check. These 2 signals are identical, so I'm going to draw them with the purple hydrogens. And then I'm going to draw in with blue hydrogens the other 2 that are identical. Now on the blue signal, the splitting is equal to 1 plus 2, so that would be a triplet, because it splits the 2 purple hydrogens. Then on the purple, the splitting equals 1 plus 3, so we'd get a quartet. And that corresponds to our spectrum, right? We have a triplet and a quartet. I've also been referring to them as quadruplets. Technically it's quartet, but either means the same thing, right? 4. So this, again, the structure we've drawn corresponds to the spectrum. So we're good. Final example here. 3 signals. It looks like we've got a singlet over here, and then a quartet here, and a triplet here. Right? It's not the clearest, but that's what it looks like. So next, my degrees of unsaturation. It's going to be 2 times 3 carbons plus 2 minus 6 over 2 to give 1. Okay, so it looks like we're going to have either a ring or a double bond. There's only 3 carbons, so it's unlikely to be a ring. There are 3 carbon rings, but they're not very stable and not very common. So likely a carbonyl. Another thing I check for, do we have any peaks that have a very noticeable chemical shift? And here we do. Right there. All the way down at 8 is the chemical shift. That would either correspond to like a benzene ring, aromatic ring, which we don't have because we only have 1 degree of unsaturation and only 3 carbons. So it's likely an aldehyde. That's around where you'd find an aldehyde peak. So I'm going to start off by drawing an aldehyde. The quartet is further downfield than the triplet, meaning the quartet is going to be closer to the oxygen than the triplet will be. So let me try drawing in an ethyl group then. So now I've got my 3 carbons. I've got 6 hydrogens and an oxygen in this. Now check for the splitting. So the green splitting equals 1 plus 2 to give 3. Right? There's 2 blue hydrogens that it splits. And the blue splitting is going to equal 1 plus 3 to give 4. So this would be the quartet. That's the triplet. And then the singlet hydrogen right there on the aldehyde. So this peak corresponds to ethyl formate is the compound. So I hope you found these NMR videos helpful. Obviously there are, hundreds and thousands of compounds that could potentially come up on an NMR, but this is the process that I always go through, right? And I'll even list it out here. So my process for solving NMRs. So step 1, note the number of signals. Step 2, calculate degrees of unsaturation. Step 3, note the splitting of each peak. Step 4, check for any outlier or identifiable chemical shifts. And then step 5, begin drawing structures / compounds and compare with NMR spectrum. I use the same process every single time I solve for an NMR. And if you follow these steps, sometimes it may take a while with a complicated NMR, but you will get to the final product. So thank you for watching these videos on NMR spectroscopy. If you haven't checked out some of the previous ones, I would definitely recommend it so you can strengthen each of the areas of chemical shift, of integration, of splitting, and I'll see you next time.